Hello, guy, and in the today's section, we will talk about the rest topic of the time series graph. And for the first of all, we come up with the scatter plot. To demonstrate for the scatter plot, that could be the purpose of trying to discuss about the relationship between two variable, and that could be sometime you hear like more popular in with the cross-sectional data when you do it on the data mining section. However, we can also do in the same philosophy for the relationship between two time series. And over here I want you guys just to discover for the electric demand data set. You click on and you can see over here this will be the half hourly and daily electric demand of Victoria, Australia in the 2014. So basically they would be the data have it three different kinds of variable, including the demand, if that's a work day or not, and the temperature of that day. We also had the elect daily, but we would just stay with the half hour time series, okay. And this would be the half hourly. So basically that would be it. And I want to take a look into the beginning of the data. Remember about what I do. So I use elect demand, okay, just to explore the data, okay. The head of the elect demand, and you can see according to what have been demonstrated in the R document. So they will be the data, the time series data start from the 2014, and we have the data of the demand, if that a work day, and the temperatures in the half hour. Now let's just go ahead and see like also the structure, okay, SGR of the elect demand, okay, and you can also see it here. Alright, in total we have up to like 17,520 observation with three variable, okay, and we gonna to plot it to see what could be the difference between the two time series of the demand and the temperature. Actually, we also have the workday variable, but not so important. I want to see the demand and the temperature. Is there any kind of relationship between them two? So, want to check for the relationship between demand and temperature, okay. Okay, so what I got to do with that, I try to, according to the book, we will try to generate for the graph, okay. And yeah, because I can easily just call out for the libraries of the tidyverse. Remember about our friend tidyverse, that's how to run everything in the pipeline function, and that say a lot of time. That's how to be make everything more straightforward. And now I would call out like elective elect demand, okay, and I wanna got the data including the C. I wanna get all the data of including the demand variable, and another will be the term operator variable, okay. And let's check it. Yeah, this will be the data, okay. So they are a lot, but actually they if we go and check and find like yeah, for example, I want to see the heading of the data. Let's check it. Yeah, this just demanded the temperature, you see it. Now let's continue and put in the autoplot function. I will just do everything in the layer into layers to make you understand about what could be the purpose behind, okay. And first of all, I just do it barely with the autoplot, and that's what I already tell you. If you put all the different kinds of time series in the same frame of the graph, sometimes they will overlap and you hardly can figure it out like what could be the relationship or any kind of pattern, because the same types of units that make everything harder to observe. So that's the reason why in the previous one we learned about the phases function, okay, and I put it here true, and let's check it how different. Now both of them have been separated into the two different graph, the time series graph, right? They still come from the 2014 into 2015. They look not so good, and I will gonna change it later. But however, at least now they will be in the different kinds of units. Like for temperatures, it from like 0 degrees Celsius to 40. Why for demand that will be from 0 into like 8 something. Okay, and now this will be the time for us to just go further with the other layers of the graph. Of course, you see over here the people don't really want to have a horizontal axis level to be like time like this, and it look ugly and kind of clumsy. So how can I do it? While that, right, I put it with the year and 2014. That means I'm start with the 2014, and you check it. Now it's a little bit like different, okay? And continue. Let's do it with the Y lab, okay? And I'm not sure because they are different in the job, so Y lab they will put in the same, okay, with the plan. And lastly, I want to have the cheesy title. Yeah, don't know why, but like even 4,000 times of that, I still cannot just type cry with the function. You do it better. Okay, and it's good be now. Okay, everything has been changed, and you got the title of the graph. You have separated two of the time series into different one, and up until now you see it like I'm zoom it out, and you see it like it looked like we had the big jump in the beginning of both, like for the temperature is jump up, and also for the demand they jump up too, and they fluctuate together, but it's still very hard because when I have a parallel time series like this, it's very hard for me to see the pattern. And this would be the time for us to move into another section. That means we go in and do with the scatter plot, okay? And the scatter plot can tell us about the relationship between two variables, and you guys should be the one who very kind of familiar with this one, and I don't want to spend it too much time. Actually I can do it, this is the same function, but one more time I will demonstrate it for you, okay? So first of all I will use the elect demand. Alright, and now would be what? This is the data. I wanna just put them into the S data set. Remember, this is not really a data set. Yes, this is not a data frame. This is actually the time series. So they cannot generate in the same scatter plot. So we have to put them into a data frame. And about the further written about the what types of data, including the vector like list, or doing with the just the metric or the data frame, you will have to read it further with the other extra tutorial in RStudio. Okay, and now I generate for the Q block. The Q block will be the function in which you can see it over here. X and Y must be have been clarified about the X axis and the Y axis. So the X axis according to here I want this should be temperature, okay, and the Y axis, or you can just put in like X equal to, right, the same thing, and Y equal to demand. Right. Let's check it first. Okay, create with this asterisk. So the mapping has some error here, and it looked like I would not be able to do like this. Okay, the demand is not found. So it look like yeah. It look like the demand and the thing will be like cannot put it in the same order like this one, and yeah, the object data plus something like that. There's some trouble with the demand, so I'm going back to the previous function. Sorry. So the previous function, it looked like for the Q plot we have to follow in the same order. We cannot generate for the different one. Yep, there's no way. Okay, and now let's add into the other layer, like for the X lab and the Y lab. Okay, so the Y lab, they should be the demand in gigawatt. Okay, that's according to what they have. And X lab label, that's it, the X label, that should be the temperature in the Celsius degree. Okay, I guess that should be enough now. Cool. And the thing will be like all the after we do all the fancy thing with the temperature, sorry, with the graph, and now it's time to tell the story. You can see like with the very low temperatures, like for example the temperatures around like 1 into like 10, you can see the demand of the electricity would be high. And you imagine about when you feel very cold in Australia, right, the time for you to turn on the heat, that can warm up of your house, and that's require and demand for the high rates of electricity. And that's the reason why the higher temperatures there will come up with the very low temperature will come up with the high demand of the electricity. However, imagine when the temperature a little bit more comfortable, when you go from like 10 into 20, where or maybe even up to 25 and even 30. So the decrease go up, but however they still be in interval of comfortable. So the people love here, and they don't want it to. They now the time for them to turn up the heater, but they don't have to open for the air conditioner to just cool down in the temperature yet. And great time now. That's the reason why they don't really need a lot of electricity. But when it go into very high temperatures, about like 30 into 40, the people now, it look like higher temperature will be higher demand of the electricity, and that makes sense. Time for us to turn on for the AC or the air conditioner right now. Okay, so the graph is quite interesting. The other thing, like this could be just the what the people call the scatter plot, and sometimes we add in the trend line. But that cannot help. That cannot help at all, because we wanna see the other numerical analysis in on the association between the two variables. So I would just not stop there. I wanna see more than that, and actually, you can do it with the correlation between both of them, including the elect demand. Okay, and then you plug in the data for the temperature. Okay, and the elect demand, when you put in for the data of the now what I say, the demand. Okay, let's check it if we can correlate. No, because it's the not atomic factor. So what I'm going to do now, let's just have to put it as data dot frame. Okay, let's see if it's possible. No, I don't think that will be good. One more time. Oh, that's not data frame. Yep, the same thing. Now electricity and the demand, and then close the parenthesis. No, it looked like we're not going this way, and I will have to first of all electricity demand, and I have to put them into as data frame. Okay. Okay, and now I'm going to check it for the call function. Now let's see it, and yeah, I put them into the data frame already, and let's see it like how they are correlated. So remember the correlation coefficient. We have learned it in the previous section, like for example the probability and statistic, or in the foundation of business analytics. So I just shortly, briefly talk about that. So if the correlation coefficient just jump between the -1 and 2 plus 1, and if they very close into plus 1 or the positive number, of course they have the positive relationship. That means one variable increase, another variable will increase too. But if they very close to 1, that means a strong positive correlation or strong positive relationship. And in the opposite side, if they are very close into -1, of course if they are the minus number, they are the kind of negative correlation. If it close into -1, that means they have a strong negative relationship. And let's check it now. Okay, it look like between demand and the temperature. This is what I want. Demand and temperature, they are interact in the correlation number of the 0.28, not that strong, but we can say like that's a kind of positive relationship, but that should not be a linear relationship, and this is a non-linear one. That's a like quadratic relationship more than that. And now let's go further with the other like advanced correlation analysis. Okay, so here I use the visit 9 data. That's your quarterly visitor nights for the various region in Australia, including like New South Wales, Queensland, South Australia, Victoria, something like that, and they cover the time frame from 1998 into 2016. And let's go and check it, like if we have any kind of like new thing about them. The data from like 76 observation with the 20 different observation. Sorry, variable. That's a lot. Let's check for the heading, and this could be how the data look like. I just care about the New South Wales Metro New South Wales, other kinds of information. So I would just need the data of the New South Wales, and that's first, second, third, fourth, and the fifth column of the fifth variable of this data. Jumping from the quarterly, yeah, that's the data, the quarterly data. Okay. Now let's go and check it. Like how can we auto plot for doing like this way? And let's just one more time do it. I wanted to use the visit 9, okay, and I want to use from 1 to 5. That should be just the data from visit 9, okay. From the first to the fifth variable, and then I choose the auto plot function and click on the faces. Remember with the reason why I put it faces equal true, right? Because I want them all be separated in the different graph, because they are different in the unit. Some of them from the 2.5 to 3.5, but the other generate from the 2 to 3.5, and the big one like from 5 to 9. So they're different in their unit, and that's better for us to just separate them into the different kinds of wrap. Now let's just add in for the Y lab. This will be for your work to do it. Okay. Look good. Okay. And now we have the Y lab. That should be the number of visitor 9 is quarter, and this look like this one. But however, because I think we have a 5 different time series, and that take a lot of time for us clarify about them. So how can I go do it with the same and like put everything, all the analysis, even the graph, the distribution, and also the correlation between the different variable into one graph? Let's do it with the libraries GG apply. You can do it at the same time, like install it like install for the packet. This will be the syntax to install for the new packet or new library. And I call out, but I already called it out, and I just had to go. And the thing would be like, I want to see it like visit 9, and I told you already, okay, from column 1 into 5, and now I want to apply for the S data frame. Remember about the reason why, because all the data here is the time frame, is the time series. It's not the data frame, it's not the variables in the same data frame, so we have to put them into the S data frame. For example, if you take a look like that, and now everything how it look like, okay, you can see it like this way. Okay, that's the data. All the data has been separated, and we don't include for the timestamp. They just be kind of like a parallel data of the different variable in the same data set. And of course, the thing I want to do will be GG pair S. And in this GG pair app, what does it mean? You can always remember about how I show you. You can always ask for the function. And this the ggplot generate a generalize for the past plot, and they provide in the matrix of the plot from the given data sets, and this is all the syntax you can fill in. But right here I would just put them in the kind of like default, and they take a little bit of time for just generate out, and the result is quite fancy. You can see over here the relationship between different variables. For example, if you really know this will be had the call for the horizontal. We had the New South Wales Metro, New South Wales Coast, New South Wales North Coast, South Coast, and this will be Southwest something. Okay, whatever. So the interaction, for example, I will show you how to read this one. So for the New South Wales Metro and New South Wales Metro, they will be interact in this graph. And what does it mean? This is the probability distribution of the graph. Okay, the same with the histogram, something like that. And another one, like for in the first, like the first triangle of the screen, you can see it like for example here the New South Wales and Coast and the New South Wales Metro, they interact in this section, in this cells, and that means the correlation between two variables, these two variables are 0.688 and they are significant. So that means they really have a strong positive relationship between them. And the same philosophy can apply in the other kinds of side. And for the rest, like in the other sides of the triangle, like in the top triangle of the graph, you can see like this is the scatter plot between the, for example, New South Wales Metro and New South Wales and Coast something. And you can see over here, this look like we have the positive relationship between them here. And do they look the same? Do they really make sense? For example, Metro and the North Coast. Now the North Coast, the where the Metro would be, this would be the Metro and North Coast. Yeah, as I told you already, this will be the relationship, have a positive relationship. And the same thing you can apply, yeah, with the rest of them. And like for Coal and the New South Wales ST Coast, they have the positive relationship, as you see. And this really makes sense, like where ST Coast New South Wales and NT Coast New South Wales, they could also have the correlation of the 0.883 and the significant relationship. And that's what I showed you about how to generate the graph in the correlation and the scatter plot analysis. Okay, let's make it fast with the last plot or the practice 2.7, the section 2.7 of the book. In this section, we talk about the last plot. That could be, in fact, the telling the relationship between the variable, I mean not the variable, but the current values of the variable and of the time series and its last value. That means the historical data of the time series. How can we do it? So first of all, I want you guys to see about the beer, the US beer. Okay, and let's see how what exactly it is. That's a quarterly Australian beer production from in like megaliters from like 1956 quarter 1 into the 2010. Oh, that's a lot of data. So let's check it and gonna see like how it looked like in the beginning. So the heads of the beer, they just kind of a totally straight time series, okay, quarter and in the different years. But however here, I don't want to see all the data because they too much, and could be the thing will be like I just want to use it for the beer function. So it start from should be from like 1992. I want just that one. So a US beer, okay, and I want to use the function window, okay, and I just want to start from 1992. Remember that the window function, they will be very useful for you to just separate, to just get a subset of the time series. You don't have, you take it, split it out, and you for the time frame a specific one, and that will be the data. Okay, so the data will be has been now cut out from the 1992. You see, into 2010 of the quarterly of the quarter 2. Okay, and would be the time for us to one more time do it for the GG's AG plot. If this really last plot, sorry, last plot. Okay, and that's will be happen to just generate the last plot of the time series. Alright, let's go and see it. This will be the last plot, and what we can see about this one. So we can see the in the horizontal, that will be the data in the current data, and also with the last one that means the data in the previous quarter, with the current quarter compared to the previous quarter, and you don't see any relationship here. And with lot 2, it look like they go not linearly, but it look like this a kind of negative relationship, and this can be caused like we had the negative relationship between the current data and the data of the 1 quarter before you. Okay, another thing like lot 3, it doesn't happen, but with the lot 4 and lot A, you see that's a positive relationship. That's mean, for example, in this could be the first quarter of 2010, and it completely have the strong relationship with the first quarter of the 2009. That's the 4 period before, right? And also with the first quarter of 2008, that's the A period before. So that's we can tell it about like in the same quarter of the year, like in 2008 first quarter, 2009 first quarter, and 2010 first quarter, they strongly correlated with each other, and this is the sign of the seasonal pattern of the data. That makes sense. Like for example, all the US beer, right? They drink like Australia beer, they drink a lot beer in the same season, like for example the first quarter of the year when they have a lot of ceremonies and they want to have the party and drink a lot of beer for fun something, while later like in just like two quarter later before that, they have the negative relationship, and the same with the last 6, like in the same way they had the negative relationship with the 2 period before or the 6 period before of the data, and that makes sense. Alright, and now let's also can talk with about the autocorrelation. Okay, now let's turn into the autocorrelation part, and we're gonna check for the autocorrelation, what exactly the autocorrelation mean. In the previous section, we talked about the correlation between 2 variables, and the autocorrelation, that means the correlation of it for the auto itself, that means the current values, are they really have the relationship or the correlation with the last value of the historical data of itself. So let's go and check it for the first one. In this one, we're going to use the CCACF. That means the autocorrelation function of the graph, and we're going to check. Oh, we don't have the data about the GGACF. Oh, that's really so sad. Let's check. Oh, I'm sorry. So they will be the ggplot autocorrelation and the cross correlation function. In here, they will produce ggplot for the ACF, and you can see all the syntax here and the argument. So that's give an ACF on an MPACF object to generate for the correlation of the autocorrelation. Wow, we're going to do it with these outer USB here one more time, and one more time I just want to just generate from the window starting from the 1992. I don't want to just make it complicated, and now I apply for the GGACF function. Okay, right, let's go and check it. And this will be the function I'm have it generated in the graph, and oh yeah, it's here. Okay, and what we can say it over here, that could be the interaction between the current values and the data in the a quarter before, 2 quarter before, 3 quarter before, 4 quarter before, 5 quarter before, and etc. Okay, so vice versa, you can see it like in the first quarter, and the current data don't have the very strong correlation, even when there's a negative one, but they're not so strong. And you can see the dashed line here, the blue line. That means if it's smaller than this interval, this limit, that means the relationship is not so significant. But if it's longer and get beyond for the interval, that means they are significantly correlated. So that happened, right? For example, with the positive relationship, the current values of the US beer, like the Australia beer, they had the positive relationship and significant for the Q4, Qa, Q10, and the Q16. That means I say already have the seasonal pattern and autocorrelation pattern in the data for the different in 4 quarter. Month, like yearly, they are in the same time, they fluctuate the same way. And the same thing, but in the opposite side, the current data of the Australia beer, they had the negative correlation with the lot 2, lot number 6, lot number 10, and lot number 12, and even here lot number that's number 10, 14, and this is 18, and they are negative relationship, but also they are they are like significantly impact, right? They are above for the dash of the blue line. Okay, and let's check it for another one. This one I will do one more time, like election, and see how will be the electricity production of Australia monthly from January of 1956 into 1995. And because of the data is quite long, so I would just select it, start from the 1998. So elect, okay, and I use for the window and start from 1980. Okay, I just want to see the data like this way, and go further. I want to do for the auto plot. Okay, and what happened here? Oh, sorry. Yeah, I have the graph here, and it looked like they have the seasonal pattern. They go up and down in the from season to season, and also we have the trend up here, right? That's a kind of like gradual, but firm and strong positive uptrend. Okay, let's add into the other laser. So the Y lab, okay, normally we can go down and put like for the Y lab, X lab, and Y X level. I want to call it a year, okay. I don't want to see Y, okay, and then plus for the Y level, okay, and I want a gigawatt hour, okay. Let's go and check it. Yeah, everything has been in the good clear now. You can also plug in for the GC title if you want, okay. Blah 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 you want, okay. Invalid argument, what happened? Oh, okay, whatever you want. Alright, and lastly, with this one I also want to check for the autocorrelation plot, okay. GGAC app, okay. This could be the plot, but the thing would be I want to specify about the last values will be up to 48 month. That's mean like 4 years later, and I gonna see like how be the data autocorrelated. It look like the closest this will be the last one, last two into last 48, okay, and the closest one like last one, the data of the previous just one previous month, they are strongly and positively correlated with the current data, and the effect just still be there, but is go down and gradually just diminish over time. That makes sense, right? And you can see it like they really have their month like the seasonal pattern. So like for every 12 months, one more time, they have a strong correlation. 12 months, another 12 months, another 12 months. Even they not so strong compared to the current data, but however they diminish over time, but still stronger than the rest of the current data. Okay. All right. Okay, the last section for the practice 2.9, white noise. A time series can be called white noise. That means without any kind of noise. When there's so no autocorrelation in the time series data. And the following example, when I try to just generate everything by myself randomly, can create a hope so a kind of random time series, and they don't have the autocorrelation in the data. So first of all, I plug in like set 30. You don't have to worry about this one. This just make sure like all the time I generate for the sets, they if you put in the same number, like with here I'm putting 30 and you hit the 30, so all the time we will generate the same result, because we go in and use the R norm. That's going to be a random normal distribution. That means they generate for the data totally random. But if you put in the different number, like I put 30 and you put 29, we generate the different time for like different data. But if we put in the same number, they will be the same. That's simple like that way. Okay, and now I would just use this for like random. I put it like TS and first of all I will say the R norm, and you will see like how exactly they are, and I clarify like I create so R norm, and you don't say anything. That means number will be 50. I want to generate for 50 number. The mean will be defaultly or 0, and the standard deviation will be 1. Okay, and we generate for the just randomly 50 number like that way. Moreover, now let's go and turn it into the time series. Okay, and now they had the start from 1 into 50 and frequency with 1, right? That's cool, that's cool. And later now I want to just put them into the auto plot. Okay, to see how the time frame that you are working. And over here you see like all the data just fluctuates without any like seasonalities, without any trend, or without any kind of like all the things will be just errors, all the things just random. So it looked like the white noise, but let's have to go and check it further to see like if there are any color problem. So yeah, of course, like here you can put in the CG title to say if it is a white noise or not, and you can generate here to just confirm about the qualities of the white noise for the data. And lastly, with the data like this, I'm going to generate for what the GGAC app. Okay, and I'm pretty sure that the data will be y naught 2, and we're going to see how they will be correlated with the graph. You can see over here all the data is belong to the limits of the significant, and even when the current data can have the relationship with the first last, second last, or the other, but they not so significant. And remember about the criteria for generate what will be the SPI and what could be the significant level of the autocorrelation function. Remember, so that will be 2 divided for the square root of t, in which t will be the length of the time series, and you're gonna check with that if the data like in the AC app values they are larger, they go belong for that number. So that means they will be have the significant level. But over here, all the thing will be less than that, and that means I can say easily the data is have no autocorrelation pattern, and they are totally white noise. And thank you for your attendance in this section.